So let's now take a step back. So in these four last notebooks, we have introduced the concepts of object-oriented programming, and one by one we have constructed classes to model European options, plain vanilla, digital options, then portfolios of options, and then we have also created the plotter class to actually visualize the options values, PNL, etc. Well, the next step in Python modelization is to organize, to coordinate these classes architecture in a package. Okay, a package is basically an organization of modules, so an organization of single files which contains typically classes or function definitions. This is what I have done, and giving it the name of pyBlackScholesAnalytics. Okay, pyBlackScholesAnalytics. So this is a package, a Python package, including all the functionalities that we have developed so far, plus so the price, PNL, option Greeks, implied volatilities, and then also enhanced visualization features for not only for price but also for Greeks, for implied volatilities, surface plus. So it's a bit dense material, not only for single options but also for portfolios of options. So it's kind of take it as a playground to familiarize yourself with from one side with object-oriented programming concepts, and on the other side with financial concept using the Black-Scholes model. So my purpose is very simple. This is a Python package that firmly steps in the middle between a student-like way of programming and a professional way of programming. Okay, so in this package you will find the concepts, some more advanced, some less advanced, coming from the object-oriented programming paradigm, and you will find the all the examples that we that are drawn for this package comes from the Black-Scholes model. So from a very simple model from the point of view of financial practitioners, but that is very well known, and that is the ideal playground for you to develop intuition, to develop familiarity with the concept. So let's quickly take a look at the architecture. We will recognize the structure of the classes that we have already introduced before, and then we will take a look at the examples that you can use to guide you through the package, which is basically if you understand the examples, you basically understand the way this package works, and you can modify them, and you can play with these examples, and basically this is the idea. So let's take a look at the Python package. Let's keep using Spider, which is our familiar editor. So the very first thing that I have created is a utility function module that contains all general purpose utility function that we might need, that we can use from our classes, but that did not make sense to include them in our classes. So these are all typical utility functions that we need to call several times from here and there, and that made sense to include in a single module, utils module. In the same utils module, you will also find the numeric routines with the numeric Greeks class implemented, that we have already seen has the Greeks, the option Greeks implementation, the numerical, the finite difference numerical approximation of options. Then here is the market environment class with the which basically implements the idea of separating the concept of a market environment from the concept of financial contracts. This is a very simple yet fundamental way of modeling things in a professional way, in which instead of writing one line by line and one contract by one contract, we are separating the variables belonging to the general market in a given date from the kind of contracts that you can read on your computer in that given date and that you may want to model. Then we have our European option class, which is an abstract class that has two subclasses, so plain vanilla option and digital option classes. We have already seen extensively these classes. The only thing that I would like to mention here is the addition, so from what we have seen above, is the addition of the Greeks, so the analytic expression for the Greeks, the computation of the implied volatility, and then a very useful method here, which is the process pricing parameters. So I have basically extended the flexibility of our class, allowing for several compositions of parameters, and we will see what I mean, and the coordination of pricing parameters, so underlying value, strike price, underlying volatility and short rate is mediated and is organized, is performed by this process pricing parameters method, which is basically called by all the public methods that perform operations. It's a utility method that coordinate parameters in input. Okay. Then we have our portfolio class, which we have already seen. Nothing new here, just the Greeks added. And here in each doc string there is the suggestion on which example to look to familiarize with the concept. For example, if we look at the price, for example, price. For example, the payoff, you can take a look at the two example options and example options other parameters to familiarize yourself with this method. So we were saying the portfolio. So here basically we have added just the Greeks, which is very simple because it leverage on the single options Greeks combined according to the position that the portfolio holds on each single constituted option. Then what we have extended a little bit is the plotter function, is the plotter class, which we have introduced. So we already had the splitting in option plotter the option plotter and the portfolio plotter, but we have added basically not only so we have added the plot surface, so and implied volatility plot, and basically we have allowed to plot not only underlying versus time, but also strike versus time, volatility versus time, and short rate versus time. So to understand and to visualize the dependencies of options or option strategies against other parameters. So the effect of different parameters on the value, the PNL, and the Greeks. So this is something that we will appreciate taking a look at examples. So let's take a look at some examples. For example, let's take a look directly at the example options to the parameters. So this script shows the usage of plain vanilla and digital option classes involving combination of all the parameters that we have in the pricing function, and for each of these combination we will compute the price, the PNL, first order Greeks, and Black-Scholes implied volatility. You can choose whether to consider if you want to consider a plain vanilla or a digital option, and then a call or a put. So basically the idea here, in each of these configuration, we are considering a different input parameter setup. For example, let's run this. Here is taking some time because it's computing implied volatility, but you see the idea is that each, for example, let's consider this case SNT vector order scalar. So it's this one. We are considering an underlying, which is a vector parameter, a time, which is a vector parameter, a strike, which is a scalar, sigma scalar, and short rate scalar. The output is either a pandas data frame or a NumPy MD array, according whether the NP output flag is set to false or true. And if you want to have a pandas data frame, the kind of structure that you have is a pandas data frame with the vectorial parameters organized in surfaces. For example, here we have both a vector underlying a vector time parameter, the pricing input parameter function that we have seen above is responsible to organize these two vector parameters actually in a grid. Okay, and more general for other combinations. Let's see if this is working. We can have a look also at plots, for example. For example, let's plot this here, for example. So this is basically this is a show-off of plotting functionalities of two-dimensional plots. So we will plot the price, PNL, delta, theta, gamma, vega, and rho for, in this case, plain vanilla call options, and this is what you get. So these are the Greeks for different times. For example, here is the vega, here is the gamma for different times, or if this is the theta, etc. for these plain vanilla options. And you also have the possibility to plotting them as 3D plots. You can take as example the example option surface. You basically, here we plot the same kind of things, so price, PNL, delta, so the Greeks, but also considering as x-axis of the surface not only the underlying but also the strike, the sigma, and the R, so that you can visualize the dependency of the options also with respect to other parameters. course this takes some time. You have the possibility to rotate your plot. This is a feature that is implemented in the plot surf method. Here we see basically the tridimensional plot of the Greeks, in which we have an x-axis, in this case still is spanned by the underlying, and then on the other direction we have the maturity, the time dimension, which can be either a date or a time to maturity. This will go on for other pricing, for other dependency. For example, here it started the strike, so here the x-axis is spanned by the strike price. So this is a plot of the surface of the strike price against the time parameter. We can leave this plot and taking a look at the portfolios. So, for example, this is an example of usage instantiation of portfolios. So here we instantiate a very generic portfolio, for example 2 strikes of call and put, and we compute the price P&L on the Greeks, and we consider the benchmark. So we compute the metrics, so price, P&L, etc., and we benchmark it against the same metrics computed, basically summing all the metrics of the constituent options, multiplied each respectively by the position defined in the portfolio. Let's take a look. So, for example, we have considered a portfolio of, so this is a portfolio which is long 2 plain vanilla call options with strike 110 and expiration date the end of the year of this year, and is short 5 plain vanilla put option contracts and with expiration date the 30th of June of next year. This is the portfolio price for a combination of 3 underlying values and 5 valuation dates, and this is the price, so the benchmark, so, and this is exactly benchmark portfolio P&L, delta, theta, gamma, and all the Greeks basically. We can also study particular cases of portfolios, for example bulk spread. A bulk spread, which is an option strategy involving basically 2 options with the same maturity but 2 different strikes, we have already seen, and we can compute the price, the P&L, and all the Greeks, and plotting them both as a line plot and as surface. It's nice. We can have a look. Let's run this. So this is the typical this is the 3D plot, and this is these are all the possible combination that you can get. This is the P&L against the underlying, and we also go to the Greeks now, and here it starts the Greeks. So this is, for example, this is the delta of the bulk spread, and this is the tridimensional plot of the delta. This is a different view, a different angle. This is another one again. This is for considering the time parameter as a time to maturity instead of dates. This is, for example, the theta of the bulk spread. This is for different dates, and this is the surface plot. So basically you have flexibility to study the dependency of your option strategies with respect to basically with the different Greeks, etc. Okay. So what else? Let's kind of show you. So basically, get familiar with examples. So it's very important. So the idea is that these pricing setups here are all meaningful pricing setups that you might encounter in real life, and that you want at least that might mean something that you may want to model. So, and this is these are all these setups pass by the process pricing parameters function that organize the different pricing setups. So for example, this is fine. And so for example, these are all that's basically it. So guys, I thank you for your time. It's already 20 minutes, more than 20 minutes of video, so I guess it's fine. And if you have questions, I will be pleased. So this is, keep in mind, this is just a first version of this Python package. It will be improved in future. So if you have suggestions of improvements, comments, feel free to write me. You will find my email at the beginning of each file. So it's gabriele.pompa@gmail.com. This is my personal email that you can use. And thank you for your attention. Bye.